Good morning and welcome back to yet another video here from the Overkill garage in sunny hot Australia. Many people have asked me if I can explain how I have set up my system here. While all these information are in the last close to 300 videos I have made here on the channel in the last year, I can fully understand if you just need a broader overview how to put things together. It is a bit cumbersome to look through all these videos in details to get these information out. And many people have asked me if I could explain how I have set up my system here, what are the thoughts behind it, what kind of fuses, breakers, cables I have used. So I thought it is time to make a drawing, to make a schematic, which shows the overall function of the whole Overkill garage system here. Okay, so this is part of the drawing now. I have tried to keep the orientation of the drawing the same as we have here on the Powerwall and battery modules, as well as the solar panel installation on the roof. And of course we are starting with the power generation on top of the roof. As you know, I have solar panels on both sides of my roof here, west and east roof. And on the west roof we have now 3.65 kilowatt peak installed. These are all 60 cell panels, so around 30 volts per panel. And I have 3 of them in a string. You can see the 1, 2, 3 here. They are in series connection, and I have 5 of these series connection then in parallel. So now you can see the west roof and the solar installation here. There are always 3 panels in a string in series connection, and I've got 5 of them in parallel on this side of the roof. 4 of these strings are 250 watt panels and 1 string is a 215 watt panel. These are all used cells I picked up from Gumtree and eBay and other online advertising portals. Here in this region, people upgraded their system and they didn't want to use the old panels anymore, so I picked them up for next to nothing and put them here on the Overkill garage, and so far they are working great. Except of the, well, you have seen the previous video, right? So, and you can also see that each of these 3S solar panel strings are connected to a pair of fuses. And again, this is something I have done. I think they have also upgraded the regulations now in Australia here, so it's mandatory to have 2 fuses in a solar string, positive and negative. I like to do this anyway. Almost everything you will see here in the drawing will be double pole breakers, fuses, switches. If I turn something off, I want it to isolate, so positive, negative, just disconnect it all together. And hence I have 2 fuses in my combiner box, one for positive, one for negative. This is the combiner box of the west roof, and with 2 fuses per string I can completely isolate them, positive and negative. So I can safely work on the roof on this string without any connection whatsoever. They have a 16 amp fuse inside, and these fuses are exiting onto a combiner bus bar. All this cabling is done with 4mm solar array cable, so this is like double and triple insulated cable we have used here. And because this is only a schematic here, I have drawn only 1 bus bar, but of course we have 2, one for positive and one for negative. And up here we can see the main bus bar system in the combiner box, positive and negative, where all the output of these fuses are connected to. And then we have 16mm cable, a pair, going down in this conduit to our Powerwall. And from here we have a 16mm pair of cables going down to another fuse box here on the Powerwall. And this enables me to quickly shut down the whole west roof at once. And this is part of the shutdown procedure here for the whole Overkill garage. And this is a 63 DC breaker. Again, double pole, positive, negative. If I turn this one off, it shuts down my whole west roof. And this is where our incoming solar cables are connected to circuit breakers here. So I can completely isolate each side of the roof with these breakers. And from here we go into a Mppt solar charge controller from Victron. It is a 150/2 70. That means it can handle solar panels up to 150 volt in a string and pushes 70 amps into the battery. So the first number gives you the maximum voltage of your solar panels, and the second one is the maximum charge current into your battery. So this solar charge controller alone can handle up to 4 kilowatt of solar panels with a 50 volt battery system. And here on the east roof, you know, we've got basically the same setup, but only 3 strings at the moment. The other 2 have not been set up because I recently discovered that 2 of my strings have faulty panels. They have little cracks underneath. There's some oxidation on the bus bars as well, some black stuff which wasn't there before when I set them all up. They were all blank and shiny. And I think it gets only worse now. So we will have to see what is going on with these panels, but I think they have to be replaced soon. But here again, it's a 3S, or 3 panels in series, which gives us around 100 volts of DC going into a pair of fuses, 16 amps each, and this exits onto a pair of bus bars in the combiner box for the east roof. And here we have the east side of the roof. Again, 3 panels in a series connection and 3 of them in parallel. And I haven't set up these 2 strings yet. All in total, we've got 2.15 kilowatt peak here. These are 60 cell panels as well. 2 strings, 250 volts, and 1 string, 215. And here as well, a pair of 16 millimeter cable exits the combiner box, goes onto a second main circuit breaker, 63 amps DC, which if I turn it off, it disconnects my whole east roof. And from here we go to the same type of solar charge controller. It is again a Victron 150-70, good for 4 kilowatt hour. At the moment is only 2 kilowatt installed, but we will upgrade this very soon. Both solar charge controllers then exit again through another circuit breaker, 63 amps DC. And this combination is mainly to completely isolate the solar charge controllers, and in case I need to work on a solar charge controller, need to take it off for maintenance, or there's something wrong, I need to replace it or whatever, I can just flick these 2 breakers and it will completely isolate positive and negative my solar charge controller. And then I can safely take it off, put another one in, a larger one, a smaller one, whatever upgrade or downgrade I need to do in the future. And we here have the incoming DC distribution panel. And these are the breakers where my solar charge controllers are connected to. So if I turn this one off and the incoming power as well, the solar charge controller of the west roof will be completely isolated from the input as well as from the output. So both solar charge controllers are then connected to our main bus bar in the battery shelf. This is the main 1200 1500 amp bus bar I have built in the top section of the battery shelf above the batteries. This is a big pair of pure copper. Yeah, this style of copper here, it's a huge massive chunk of copper I have bought when we built the battery shelf, and there are 2 bus bars, one for positive, one for negative in this compartment, and everything connects to these main bus bars then. And here we can see the main bus bar system, negative and positive of the off-grid garage. Everything is connected to this main bus bar system here in the top area of the battery shelf. So let's have a look at the battery shelf then while we are there. We have 3 battery banks at the moment here in parallel. These are 16S lithium iron phosphate batteries. So we have 16 battery cells in series. In the top shelf we have a 304 ampere hour battery, 48 volt, which gives us around 15.5 kilowatt hours of energy. It is connected to a 100 amp Overkill solar BMS for testing purposes at the moment. This is the BMS Maddie has sent me from Canada because she upgraded to a JK-BMS and didn't need this one anymore and thought I can do some testing with it, which we have done in previous videos already, and the BMS is working totally fine. It is a rebranded JBD, the world famous Jabata BMS, but Overkill Solar uses the JBD technology to rebrand them as Overkill Solar, while they also upgrade the connection cables to thicker ones. Well, we have all seen this in these previous test videos. And from here we go on to a molded 100 amp DC industrial circuit breaker. And I've chosen these ones because they are really massive. They act as a main switch as well for this battery bank, and they have a breaking capacity of 25 kilo amps. This is 25,000 amps. And I really like the functionality of them, that I can quickly shut down a whole battery bank for whatever reason. If I want to do maintenance, if something is not right, if something goes out of whack, I can just pull the trigger here and I isolate my whole battery altogether. And here we can see the battery shelf with 3 separate battery banks, lithium iron phosphate, connected to their own BMS each and with their own individual circuit breaker. So we can see the label of the no arc circuit breaker here, 25 kilo amp of breaking capacity. And these circuit breakers are also main switches, so I can just turn off 1 or 2 of these breakers here and the whole system will now only run from the bottom shelf battery, because these 2 are completely isolated now. Positive, negative, terminated. From the vertical busbar system we can see there in the back. See, this busbar system goes all the way through until the bottom of the shelf. And once we are done with the fault finding or maintenance, we can just reintroduce these battery banks again, and they will balance out each shelf now with the remaining battery bank. You can see the order here, BMS close to the battery and then the circuit breaker, and not the other way around. If there is something wrong with the battery and I need to isolate it, I can do this with the circuit breaker, but the BMS still stays connected, and I will be able to use my mobile phone then to connect to this BMS and read out all the parameters of the cells, and can actually investigate and troubleshoot the battery. That's why I opted in for this order. BMS first and then circuit breaker the second. And I think the battery and the BMS are one unit, and they should always stay together. And we've got a similar setup here for the battery in the middle shelf. It is as well a 16S lithium iron phosphate battery with 280 ampere hours. These are the EV-LF280N cells, the old style with the flat terminals and the hole drilled into it. And I have used Paul's aluminium bus bars here to connect all these batteries together. I have not polished, I have not sanded, I have not treated these terminals in any form. The battery came like this out of the boxes into the shelf. I've connected the aluminium bus bars. There's no paste, no grease underneath, nothing. And it just works totally fine. We've got the 200 amp JK-BMS connected here to this battery bank in the middle, and also a 100 amp DC molded circuit breaker here to isolate the battery in any case. And the bottom shelf battery is the EVE-LF280K. These were coming with the welded studs, and I have used the copper bus bars which came with the battery cells. This is connected to a 200 amp Heltec BMS, which we are testing right now as well. So I've got 3 different BMSs here connected to each of the battery bank. And this runs then through a 100 amp circuit breaker DC as well to isolate the battery in case of maintenance or fault. The exit or output of the circuit breakers goes to a vertical bus bar in the battery shelf, which goes all the way up to our main bus bar again. See, this vertical bus bar and this horizontal bus bar here are connected through my smart shunt, which gives me actually the state of charge. So while these BMSs give me the individual current going in and out of each battery bank, the smart shunt will give me the information for my whole battery as such. And from here we go into a main battery breaker and switch with 250 amps. This is one of the big industrial molded circuit breakers again. If I turn this one off, it isolates my whole battery from the system. And here to the main horizontal bus bar system, we have also connected a 10 amp double pole DC breaker. And this supplies power to a DC to DC converter, which converts 48 volt to 12 volt with 20 amps. And we have also a 48 volt to 5 volt DC to DC converter here, which then supplies 5 volt to our Raspberry Pi, which is the main central data point in my system. And this then hooks up to the Victron VIM, so I can have remote access to all these components here through my mobile phone from wherever I am. And this is not only for monitoring purposes, I can also change parameters here in all Victron devices with my mobile phone if I'm at the beach and having a nice barbecue there. I can quickly log in and change the parameters in the solar charge controllers. I've done this many times, but at the moment everything seems to work just fine, so I'm less and less changing parameters remotely. And this is then our low volt section here. This is a separate department in the top battery shelf. We also have a 10 amp DC breaker, positive negative dual pole, and a 48 volt to 5 volt converter. This supplies power to our Raspberry Pi here, which runs the Venus OS software. And we have another DC to DC converter here, 48 volt to 12 volt with 20 amps. And this supplies power to this little distribution panel down here. And we have a 12 volt cigarette lighter output here, as well as QC3 USB chargers for my cameras and other gear. 2 more 12 volt outlets here. One supplies power to the router, and the other one is for a charger, which I can directly connect to my 12 volt system here. And this section is completely separated here with a clear plastic from the 48 volt section. So we've got the 48 volt section here, and then the separator and the 12 and 5 volt area on this side. So, and here on the right we can see our inverter and AC section of the system. Again, this is connected to our main horizontal bus bar. We have 2 fuses in here with 200 amps each. And they supply power to our inverters. One of them is a Multiplus 2 from Victron, and the other one is a Phoenix Inverter Smart. The Multiplus has 5 kVA, while the Phoenix next to it has 3 kVA. And over here we can see the 200 amp fuses for both of the inverters. They are connecting with a copper bus bar to the main bus bar system here. So this is the positive link. And I've opted in for the fuses here because, well, I followed the procedure and installation recommendation from Victron here, and they recommend a 200 amp fuse in the positive line of the inverters, while the negative line stays always connected to the inverters. I'm not super 100% sure why that is, but I think it has something to do with the communication of the inverters to the rest of the system. And if you have a breaker which disconnects both positive and negative, there could be actually power going through your communication cable, which will burn it out immediately. So the installation says leave the negative always connected to your inverters. So hence we have a little bit of a different setup here for these inverters. And each inverter also comes with a 300 amp DC main switch to quickly turn off the inverter in case of an emergency or maintenance. And both inverters are connected to a AC distribution panel on the side here, while the Phoenix actually does not supply any power directly here to the garage or any other load. So the Multiplus is running all the time 24/7 and powers the garage, the pool pump, and also charges my vehicle if there's enough energy in the battery, of course. But it powers the garage, it runs the pool pump around the year. That is no problem at all. So the programming of the Multiplus is now like this. If the power output of the Multi is larger than 3 kilowatts for 1 minute, it starts the smaller Phoenix inverter here as well. And the Phoenix will not take over some of the load then. The Phoenix inverter will actually supply up to 2 kilowatts into the Multiplus. And then the Multiplus only adds additional energy on top of that. So for example, if we have a 5 kilowatt load, the Multiplus would turn on the Phoenix inverter. This supplies 2 kilowatt to the Multiplus, and the Multiplus would then add another 3 kilowatts on top of that to reach the 5 kilowatts we actually need for our loads. So 2 kilowatts from here, 3 kilowatts from here, and this works very, very well. So, and here at the moment we have exactly this scenario where both inverters are working in conjunction. So we've got the Multiplus turned on and assisting the Phoenix inverter with the load. So having a look at the system here, we can see we have a total load of 4,200 watts at the moment, and the generator, which is our Phoenix inverter, the small one, delivers 1.8, 1.9 kilowatts, and the Multiplus in the middle, the blue box, is assisting. And we can see this here. The inverter is on and it's flashing, and the mains are on as well. So that means we are getting an AC input signal from this inverter. This output is connected to this input, and this one is then assisting this inverter to reach the 4.2 kilowatts. So most of the time this inverter will not be used at all. This is just for the high output loads. But again, this was more like a test setup to see if this combination actually works, if we can put these inverters in series. They are not in parallel, they are not powering loads individually, they are in series. One inverter is supplying power to another inverter, and the other inverter adds power on top of that. So it's a very interesting setup, and basically in AC1 there's only one breaker, a 16 amp breaker in here, which is the connection between the Phoenix and the Multiplus. I have just put a separate breaker in between to isolate these two from the AC side. And down here in AC2, this is my main distribution panel for light, for all the power outlet, for the car charging, for the pool pump, and I think there's one spare in there as well. And here we have both AC distribution panels. AC1 contains only this one circuit breaker here. This is basically the link between the Phoenix inverter and the Multiplus. It's just for testing and maintenance purposes. I can turn this off and disconnect these two inverters from each other. While the AC2 distribution panel here contains the main power distribution for the garage, the pool, and the electric vehicle charging. And this one is powered 24/7 by the Multiplus. So this is how they have been set up so far. Eventually I will replace this Phoenix inverter with another Multiplus and probably use this one again for one of the Multipluses to add additional 2 kilowatts if needed. But this is all future. I don't know what's coming. So, and here's the inverter section of the power wall. We can see both inverters there and the cable run. So DC is coming from the bottom to the inverters through the main switch for each inverter, and AC is going up to the top and going over to the right here to the AC distribution section of the power wall. And this was as per design, so we don't have any crossings from AC and DC cabling. And you can also see this green double line here coming from the solar charge controllers as well as the smart shunt and the inverters. This means communication cables are connected to our Raspberry Pi, which runs the Venus OS at the moment. It's the central unit for all my communications, everything. This collects all the data, all the information together and presents this to the VIM. And here's the complete overview over the whole system now as such, with the solar panels, the solar charge controllers, the main distribution bus bar system, the battery shelf down here with the breakers and BMS, and the second vertical bus bar system connected to a shunt and main breaker. And on the right we have the inverter and AC panels connected. So this gives you a good overview what the current situation of the system is. And here's another overview over the power wall. We can see these three sections. We've got the DC incoming distribution section on the left, the DC to AC conversion section in the middle, and the AC distribution section on the right. As I mentioned before, there is a shutdown procedure for the whole system, and it involves only 3 circuit breakers here you need to shut down to isolate everything altogether completely. And this is MCB1, This is our incoming solar from the west roof. MCB2 for the east roof, and the main battery switch. I'll show you this here quickly. These are the solar isolators here for the garage. If I turn this one off and this one off, there's no power coming in anymore. And then I pull this one down. This is the main 250 amp DC switch. This isolates all our batteries and everything will be dead afterwards. So this takes you less than a second to isolate the whole system, to turn everything off in case of an emergency. So I hope this gives you a detailed overview of the off-grid garage now, what we have installed here so far. This may change over time, but I will try to keep this one updated as well. I hope you enjoyed this video. I hope you learned something. I hope you had fun. And I especially hope this all makes sense, how I have set up my system here. If you have any further questions, please leave them down below. As always, guys, thank you so much for watching. Thanks for all your amazing, great support here, especially people who are financially supporting the channel here, but also everyone else who is leaving comments, likes, and sharing these videos everywhere. This is all very much appreciated and helps a lot to support the channel here and enables me to make more videos like this. Until the next video, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye-bye.